All right. So we're going to go over a few questions from the Chapter 7 review worksheet, which is due tomorrow. Part 1 of your test is tomorrow, and it is the non-calculator portion. So no calculator, there should be no reason to use a calculator. On Monday will be the application portions, and an application involves obviously using word problems and decimal values for rates and stuff like that. So you'll have to use the calculator on Monday's portion. So if you can take out your review. Yesterday, we went over 1 and 2 together as a class. There were a few others that I just wanted to kind of note or highlight, just kind of make sure you understand everything that's going on with the question. So the directions for 15 and 16, that's where I'm going to look right now. Say write as a single logarithm, and then it says evaluate. Not every logarithm will you be able to evaluate, but some of them you can. So if we look at 16, Brooke, how would you start with number 16? Yeah. Right, yeah. So to condense them together, it's called the product property. You multiply the values after the log together. So you're condensing those values. 5 times 125 makes? Yeah, 625. All right. So if you chose to continue to condense this log, because it does say to condense, subtraction means they would condense into division. And again, you're dividing the quantity or the numbers after the log. So you're not actually dividing the log itself because that's the function. It doesn't get divided. It's the quantity or the numbers after the function that get divided. And so this would become the log base 5 of what? So it did say to condense. So that is condensing the log as a single logarithm, or writing the log as a single logarithm. The second part says to evaluate, which means if it can be simplified further down to a single number, then you need to do that. An easy way to check to see if something can be evaluated is just by setting this equal to x and changing it into exponential form. So if I wrote this as an exponent, we're looking at 5 to the power of x equals 1. Well, what power of any number would make the value 1? Gabby? 0. Now, you can also see that from this first expression that it's going to become 0 because you have the log base 5 of 625 minus the log base 5 of 625. That's another way of looking to see that it's going to be 0. X minus x is 0, 7 minus 7 is 0. The log of 5, log base 5, 625 minus the log base 5 of 625 is 0. So there's a couple of ways that you can think about that. But the question did say to condense to a single log. So we do need this part here. And then evaluating it, it's equal to 0. Questions with that? All right, if you continue on and look at number 20, a lot of you are like missing a step here when you're solving for logs. Alyssa, when it has a plus sign, what would we do to condense the logs on the left side here? Yeah, we would multiply. So we've got the log base 7. That part doesn't disappear. You're multiplying x minus 2 and x minus 8 together. So that gives us x squared minus 10x plus 16. And it's equal to 1. So again, you're multiplying the expression or quantities that are after the individual logs to condense them. but the log base 7 doesn't go away. So after you condense, how does the log go away? And I'm putting quotes around that. So when you condense, Faith, what do you do next then with the log base 7? Yeah, you need to write it as an exponent. So the log doesn't just disappear, but instead you're writing it in its exponential form, which is its inverse form. So you have 7 to the first is equal to x squared minus 10x plus 6. And a lot of you are missing that step. You're just making the log vanish. It doesn't vanish, you're just writing it in its inverse form. So I think this is a 16 here. There we go. So we have x squared minus 10x plus 16 equal to 7. Jaden, then what would we do?
Subtract 7 over the other side.
I'm going to back to this. 9. What's your numbers multiplied to be 9, but add to be negative 10? Yeah. A negative 9 and a negative 1 make 10. And then my two answers are a positive 1 and a positive 9. Now here's the other part. Both of those answers are positive. However, you need to check to see, do they make the actual log negative or the quantity that's after the log? So if you take the value of 1 and you plug it in for x, if I have 1 minus 2, now I have the log of negative 1. And if I have 1 minus 8, now I have the log of negative 7. Positive 1 is not a solution because it makes the quantity after the log negative. So just because x equals 1 is a positive number doesn't mean it's always a solution. It's when you plug it back into the expression after the log. So 1 does not work because it made that expression negative. If I plug a 9 in, 9 minus 2, 9 minus 8, well, that makes 7, and that makes a positive 1. 9 is okay because whatever remains after the log is still positive. Questions on that? I want to make sure we're getting any misconceptions clarified. Yeah. So number 14, this one wants us to expand, and it says write each expression in terms of log x and log y. So the first thing here, what's happening with y to the 5th and the square root of x? What's the operation between there, Alyssa? Right in here, we're adding, subtracting, multiplying, dividing. Multiplying, yeah, these two are being multiplied together. So first, we're going to separate them. So they're being multiplied. We're going to rewrite these as 2 individual logs into addition. So that's the product property. It's being multiplied, expand into addition. And then the square root of x, I'm going to change as an exponent in this same step. We know a square root is really the exponent of a half. You have to expand first, though. After you expand, Jordan, what would you do next to continue to expand this problem?
I don't know, you move the exponents to the front.
Yeah, that's called the power property. So the powers move to the front and become multiplication. So this is now 5 times the log of y and a half times the log of x. So first separate it, product property, into addition. So product separates into addition. And then the second one, the exponent, it's called the power property, moves in front and you're multiplying the log. And that's because the power property of exponents, you multiply the exponents together when it's the power property. So you're still multiplying, you're just multiplying it in front of the log. Questions on that? So there's one other one that I wanted to look at, and it actually was the last problem. So the last problem is an exponent problem. We have 10 to the 2x plus 1 minus 2 equals 2. Colleen, what do you think you would do for number 26 to start this one? Yeah, so get the exponent part to be by itself, isolate that. And then what would you do? Right, so once the exponent is by itself, there's nothing else we can do with that exponent form. We're gonna have to write it as a log. So the base is 10. You don't have to write that there when it's a 10. It's implied to be a 10. Of 4, and then 2x plus 1. So the first thing you need to do is find out what that log of 4 is. I think a lot of people are subtracting 1 from that value. But the log of 4 is kind of grouped together as itself. So if I continue to solve for x, I would have to subtract 1 and then divide by 2. But the log of 4 goes into the calculator. You're not subtracting 1 from 4. You're subtracting 1 from this number once you plug that in the calculator. So plug the log of 4 in the calculator, hit enter, subtract 1, hit enter, and then divide all of that answer by 2. Questions on that? So that question would not be on tomorrow's test because you got to use a calculator, and I don't want you to use a calculator. So you would have a question that you don't have to use a calculator for. Jane.
Are we allowed to have our power sheet for the test?
Yeah, you can have the power sheet, sure, yeah. Other questions? All right, so I'd like you to go to Kahoot because I thought we should do some type of different review. So if you want to go to kahoot.it. Just get a different way to review today. All right, so after you're at Kahoot.it, I'm going to pass out paper for those of you that are in here. So Jaden's on it. She's already getting out her paper. If you're at home, you'll want some scratch paper to use. But I have scratch paper that I can hand out. I would say take maybe 2 pieces. Pass it back. Okay, you're good. So take a couple pieces, pass it back. If you don't use all of it, we'll just recycle it. No worries. Again, if you're at home, you will probably want to have some type of scratch paper with you. All right, everybody have a calculator out? If you will need it eventually, so get a calculator out. I do have some word problems on here. And I have hard candy for the winners. I can open the hard candy. If you're at home, I'm not sure what you win. Just the validation of being the best in the class. That's good enough. Let me get the sound going. I don't know why there's no sound. Here it goes. So logs and exponents, what type of functions are they? Therefore, they reflect over the line y equals x. I like the last one. They could be twinsies. So inverse functions. So logs and exponents are inverses. When you write one to the other, you're writing it in the inverse form. I'm glad nobody picked twinsies. That's good. All right. Write this in log form. So that's the exponential form. Not sure why it's not showing up. Oh, there it goes. Like, it might be frozen in here. Let me see. Oh, okay. So evaluate. Write this as an exponent. So change it to exponential form, and then what would it equal? Good. So there's our log function. Can you write it as an exponent? People moving up in here. Anybody like biscuits and gravy? I could eat biscuits and gravy with a side of eggs, maybe. So the 2 moves up to square the 5. Remember, the 1/2 is really taking the square root of 25. So move the exponent first, then pull them together, but you got to move that exponent first. Lots of people moving up here. Good. So expand means you want to write this in separate logarithms. Brooke, you can always move your desk if you can't see kind of directly on. So that last pair, the BC was in the denominator. What A, the square root of A. So separate them first. When you separate these, yes, it becomes addition, but this minus sign goes to everything. So that's why it's grouped together in parentheses. So when I expand BC, yes, I'm adding them together, but that minus sign goes to both of those quantities. So that's why this is grouped in parentheses here. Pretty much if it's in the denominator, it needs to have a minus sign in front of it because that shows you're dividing that. So it goes to the denominator. Questions? So what type of function is graphed? Is it quadratic, exponential, growth, exponential, decay, or is this a logarithmic function? So it is actually a logarithmic function. An exponential function has a horizontal exponent. So it either grows or it decays, but its asymptote, not exponent, asymptote is horizontal. So the logarithmic function has the vertical asymptote, and that's the graph that was shown. So you knew it was increasing, that's good, because it was an increasing graph, but it was actually an increasing log graph. Ooh, big move change there. Big shift. All right, so word problem here. We haven't done one of these in a little while. Your allowance raises 15% each year. After 5 years, it's up to 20 bucks. What was your starting allowance? So you have your initial 1 plus the rate to the power of time. That's our exponential growth function. Your goal is to find out the initial amount. We know the other information. So we want to figure out what is the starting amount. That is our exponential growth model. Y equals A times 1 plus R to the power of T. So this type of question would be on Monday's portion. So I don't know if that $20 is $20 a week or I would hope $20 a day seems like a big allowance. I don't know. My girls don't get allowance. Does anybody get an allowance? You do? Yes, a couple of you? Do you get $20 a day? No. Okay, that would be pretty nice allowance though. Maybe if you're babysitting your siblings or something like that. That might even just be forced. Are you forced to babysit your siblings for free? Yeah. Uh-huh. All right, solve for x. So now we got an equation. Log base 6, x minus 8 equals 2. So you would write it in exponential form and then add 8 to the other side. The base was 6, so 6 squared is equal to x minus 8. All right, identify this graph. Good. So this is decaying because it started up at the top. From left to right, it's going down. So reading from left to right, it started up and then it moved down. Still had that horizontal asymptote. What's the domain of an exponential function? So think of the graph that you just saw. What's the domain of that graph? Doesn't matter that it was decaying. It still has the same domain as a growth graph. So what was that domain? So domain negative infinity to positive infinity. That's for an exponential function. That means x is allowed to be anything. You're allowed to plug in any number for x when it's an exponential function. The domain of a log function is 0 to infinity. So the log, remember, you can't have a negative number or you cannot have 0. So the domain for a log function is 0 to infinity. Another word problem here. So our buddy Joe is investing money. He invested $1,800 with a rate of 6.8% compounded quarterly. That's the N. How many times a year has it been compounded? Find when the value is $5,400. So you know the initial amount, you know the end amount, you know the rate, and you know the number of compoundings. You're trying to find time here. So think about solving the exponential equation for t, for time. So try and get the exponent to be by itself. How would you get rid of the number in front of that exponent? And then write it in logarithmic form.
Can we just guess? Because that took too much time.
So the first thing that you would want to do, divide by 1,800. What is 5,400 divided by 1,800? 3. And then the next thing I would say is get a decimal value for this right here. So take 0.068 divided by 4 and add 1 to it. Gabby, you just did that, I think. What did you get there?
1.017.
All right. So now there's nothing you can do in exponential form, which is why we have logarithms. This 1.017 is your base. So I have the log 1.017 of 3 equals 4 times t. This goes in your calculator. You have that log-based function under the math. So under math, you're placing log 1.017 of 3. And then that whole answer, you're going to divide by 4. This will be a Monday's test. You might want to star it, write the problem down so you know to look at it. But you will see something like this on Monday. You'll be asked to solve for t. So this is still solving an equation. It's just starting out in a word problem form. Questions on this? Nice job, Alyssa. Hanging out up there. All right, another equation here. Solve for x. Got a little small. Cody, can you see it back there?
Does the bottom log say 20?
20, yes. Yeah. So log base 20, 8 minus 2x equals log base 20, negative 3x plus 10. So the base was the same, 1 log on the left, 1 log on the right. Take the expression after the log, property of equality for logarithms, set them equal to each other. So that happens when you have 1 log equal to 1 log. I'm going to skip this one to see if we can get to another one that's a little shorter.
Yeah.
See what this one looks like. All right, so this is property of equality again. The base is 11. 1 log equal to 1 log. And I think this will be our last one. So as you're solving this one, tomorrow's test again, no calculator. Those of you at home, you will be given a test. You'll be asked to sign a specific statement on that test. Everybody in here will get a paper test. The paper test the last time went so much better than the iPad, I think. So it will be on paper. That one you had to factor. The key thing was the left side had a -8, so you could have a negative answer there when you substituted it back in. All right, so let's end this thing. Oh, I should have looked to see who is. Everybody at home won.
Oh, we were fourth.
So Jaden and Gabby, there's hard candy up here if you want to grab a piece.
Thank you, I'll get it.
My,
If we have a power sheet for tomorrow, you want it on paper?
that would be nice, yes.
Okay.
Yeah, so if you have a power sheet and you want to use the common power sheet, if you could print that out, that would be fantastic. Any other questions for tomorrow? If you do have them and you're in school, obviously ask during homeroom. If you're at home, feel free to join Zoom and you can ask then. Have a fantastic day. Nice job, everybody at home.